Tesla's self-driving car may already work, so why isn't it everywhere? That question sounds simple, but the more you dig into it, the more you realize that most people are asking the wrong question entirely. For years, the debate has been about whether the technology works, whether the artificial intelligence is good enough, whether the cameras can see what needs to be seen, whether the software can make the right decision at the right millisecond. And that debate has consumed billions of dollars, thousands of news articles, and an enormous amount of public trust. But here is what almost nobody is talking about right now. What if that debate is already over? What if the technology question has been quietly answered, and the real battle has moved somewhere else entirely, somewhere most people are not even looking? This is not a review of Tesla's software updates. This is not a breakdown of neural network architecture. This is an investigation into what is actually holding self-driving cars back from your street, your city, and your daily life. Because the answer may surprise you, and it has almost nothing to do with artificial intelligence. Let us start with what we know. Tesla's full self-driving system, the version currently operating in the real world, has been accumulating data at a scale that is almost impossible to comprehend. As of February 2026, Tesla vehicles have driven 8.4 billion cumulative miles with full self-driving engaged. That is not a projection. That is not a marketing number from a press release. That is a real-world dataset that no other company on the planet comes close to matching. And inside that dataset, something important happened. A metric called miles to critical engagement, which measures how far the system drives before a human driver needs to take over in a genuinely dangerous situation, jumped from 441 miles to 9,200 miles after a single software update in October 2025. That is a 20-fold improvement, the largest sequential advancement in 4 years. To put that in terms that actually mean something, if you are an average American driver covering 13,000 miles per year, the current version of Tesla's full self-driving system could theoretically operate for roughly 3 years without a single critical failure. 3 years. That is not science fiction. That is a metric from a software update that most people did not even notice. And it does not stop there. In Austin, Texas, where Tesla has been running its robotaxi pilot program, the vehicles are logging 40,000 miles between incidents. Not critical failures. Incidents. The kind of minor events that human drivers experience every single day without a second thought. 7 events were reported to the National Highway Traffic Safety Administration over approximately 280,000 miles of operation. Piper Sandler analyst Alexander Potter, one of the most respected voices in automotive investment research, looked at all of this data and said something that should be headline news. Tesla is likely very close to eliminating safety operators from its Austin robotaxis. Not in 10 years. Not after the next generation of hardware. Very close. Now. So if a Wall Street analyst is saying Tesla is very close, and the data shows a 20-fold improvement in safety metrics, and 8.4 billion miles of real-world training data exist, why are there only 44 Tesla robotaxis operating in one city in America? Why is the technology not on every street in every city right now? That is the question this video is actually about. Here is the thing about technology and scale that most people never think about. They are completely different problems. The history of every transformative technology is littered with examples of things that work perfectly in a lab, or in a pilot program, or in a controlled environment, and then took another decade to actually reach the people who needed them. The technology was solved. The scaling was not. Think about commercial aviation. The Wright brothers flew at Kitty Hawk in 1903, but the first scheduled commercial airline flight did not happen until 1914, and air travel did not become something ordinary Americans could afford until the 1970s. The technology worked. But the infrastructure, the regulation, the liability frameworks, the trained workforce, the standardized safety protocols, all of that took generations to build. Think about smartphones. The first iPhone launched in 2007, but it took years of carrier negotiations, app store regulation, data privacy law development, and consumer trust building before smartphones became the essential infrastructure of daily life that they are today. The gap between working and scaling is where most technology goes to die, or at least to wait for a very long time. Tesla is standing at that exact gap right now. And the obstacles between where Tesla is today and where it needs to be are not engineering problems. They are regulatory problems, liability problems, public trust problems, and operational scaling problems. Let us go through each one because each one tells a different part of the same story. Start with regulation, because it is the biggest bottleneck by a significant margin. There is currently no federal framework in the United States for certifying a Level 4 autonomous vehicle. The National Highway Traffic Safety Administration was not built to validate full autonomy. It was built to evaluate specific hardware components and respond to crashes after they happen. There is no pathway, no checklist, no process by which Tesla can submit its software to a federal body and receive approval to remove the human driver. That framework does not exist. Elon Musk said it directly in June 2026. It is a regulatory issue, not a capability issue. And that matters, because Musk has financial motivations to downplay technical problems, but very little incentive to blame regulators if the technology itself were truly the obstacle. At the state level, the situation is equally complex. Every state in America has different rules governing autonomous vehicle testing and commercial operation. Texas has been relatively permissive, which is why Austin is the only city where Tesla's robotaxi program exists. California, the state where Tesla's most vocal critics reside and where most of its vehicles are sold, has been openly hostile. The California Department of Motor Vehicles suspended Tesla's sales license, alleging that the marketing terms autopilot and full self-driving give consumers a false sense of what the technology can actually do. Tesla fought back with a lawsuit. The result is that Tesla has logged 0 miles of autonomous testing on public California roads in all of 2025. 0. The state with the most Tesla vehicles on the road has completely shut the door on any autonomous operation. And Musk's own timeline for expansion, reaching 25 to 50% of the United States by the end of 2026, hinges entirely on regulatory approvals coming through state by state. That is not one approval. That is 50 separate negotiations with 50 separate bureaucracies moving at 50 different speeds. Then there is the National Highway Traffic Safety Administration investigation. 3.2 million Tesla vehicles are currently under what is called an engineering analysis, which is the step before a potential recall. The investigation stems from 9 crashes involving full self-driving, where the system may have failed to detect hazards in low visibility conditions. Tesla's software update addressed 3 of those 9 crashes. The other 6 remain under scrutiny. This is not a small problem. A recall of 3.2 million vehicles would be the largest autonomous vehicle safety action in history, and it would set back public acceptance of the technology by years. The investigation is not resolved. It is ongoing. Europe adds another layer of complexity. The regulatory framework governing vehicle type approval in the European Union operates under United Nations Economic Commission for Europe standards, and those standards were not written with artificial intelligence in mind. Regulators in the Netherlands and other key markets have expressed concerns about camera-only sensing systems, since most European regulatory frameworks were developed assuming sensor fusion with radar and LiDAR. Tesla's camera-only approach may be technically superior, but it does not fit neatly into the existing approval architecture. European rollout of any version of autonomous Tesla operation is delayed until at least 2026, and that timeline assumes the regulatory review goes smoothly, which it has not so far. Now let us talk about liability, because this is the problem that keeps insurance companies, lawyers, and hospital executives awake at night. When a human driver causes a crash, the liability framework is clear. The driver is at fault, the driver's insurance pays, and the legal system has 200 years of precedent to draw on. When a fully autonomous vehicle causes a crash, everything changes. The liability shifts from the driver to the manufacturer of the system that made the decision. That means Tesla, or whatever company owns the software, becomes potentially liable for every crash involving every vehicle running their system anywhere in the country at any time. There is currently no insurance product designed for personally owned fully autonomous vehicles. It does not exist. The insurance industry has not figured out how to price a risk it cannot yet quantify. And the class action lawsuit already filed in California by drivers alleging that Tesla's marketing was deliberately misleading creates a legal cloud over the entire enterprise that will take years to resolve. Tesla Insurance, which has direct access to vehicle data, is probably the best positioned product to eventually fill this gap, but that product does not exist in its necessary form today. Public trust is harder to measure than regulation, but it may be the most important long-term factor. Stanford Law professor Bryant Walker Smith, one of the leading academic experts on autonomous vehicle law, has described the regulatory process as a kind of whack-a-mole, where the technology moves faster than any framework can keep up with, and every solution creates new problems in a different jurisdiction. That dynamic erodes public confidence not because the technology is dangerous, but because people cannot tell the difference between a genuine safety concern and a regulatory turf war. When they see headlines about NHTSA investigations in California, sales license suspensions and class action lawsuits, the average consumer does not parse the nuances. They see chaos. And chaos does not make people want to sit in the back seat of a car with no driver. This brings us to the Waymo comparison, because it is the most instructive case study available. Waymo has approximately 3,000 autonomous vehicles operating across 10 metropolitan areas, including San Francisco, Los Angeles, Phoenix, Atlanta, Austin, Miami, Dallas, Houston, San Antonio, and Orlando. By the end of 2025, Waymo was completing 400,000 paid rides per week, entirely without human safety drivers in select markets. That is real scale. That is a real commercial business. And Waymo got there by taking a different approach than Tesla from the beginning, using LiDAR, radar, and cameras together rather than cameras alone, investing heavily in regulatory relationships in each city before launching, and accepting a slower rollout in exchange for deeper regulatory trust. But here is the lesson that nobody talks about when they compare Waymo to Tesla. Even Waymo, with its more conservative approach, its institutional backing from Alphabet, and its years of regulatory goodwill, is still only in 10 cities after more than a decade of development. Even Waymo faced a safety review after one of its vehicles had an interaction with a school bus. Even Waymo has had to navigate the same state-by-state regulatory maze that Tesla is facing. The difference between Tesla's 44 vehicles in one city and Waymo's 3,000 vehicles in 10 cities is not a difference in technology. It is a difference in how many years each company has spent building the operational and regulatory infrastructure to support deployment. Tesla is earlier in that process. Not behind technically, but earlier in the entirely separate problem of scaling. Think about what national scale would actually require. Right now, Tesla has 44 vehicles in Austin. A national network would require not hundreds or thousands, but potentially millions of vehicles across 50 states, each operating under different rules, each requiring local maintenance infrastructure, each connected to real-time monitoring systems that track software performance across the entire fleet simultaneously. Managing a software update for 44 vehicles in one city is a completely different engineering problem than pushing an update to 1 million vehicles operating in Boston snowstorms, Phoenix heat, Seattle rain, and Miami humidity all at the same time. The edge cases that a robotaxi encounters on one street in Austin will be completely different from the edge cases it encounters on a rural highway in Montana or a dense urban intersection in Chicago. Every geography introduces new variables. Every variable requires new training data, and every deployment in a new city requires a new round of regulatory negotiation. So here is the question worth asking. If Tesla solves these problems, what actually happens? Not in the abstract, futurist way that technology commentators usually discuss, but practically, economically, for real people and real industries. The American trucking industry employs approximately 3.5 million drivers. The taxi and rideshare industry employs another 1.5 million. Insurance companies collect approximately $250 billion per year in auto premiums, a business model built entirely on the assumption that human error causes most crashes. Parking infrastructure in American cities represents a real estate asset worth trillions of dollars. All of that changes in a world where autonomous vehicles work at scale, not slowly, not gradually, but with the kind of speed that a technology company operating at Tesla's scale can potentially move once the regulatory and operational gates open. The question is not whether this happens. The question is when the remaining bottlenecks disappear and what the world looks like the week after they do. Here is what the evidence actually shows. The technology has advanced further than most people realize. A 20-fold improvement in safety metrics is not an incremental upgrade. 8.4 billion miles of training data is not a prototype. 40,000 miles between incidents in a live commercial robotaxi program is not a publicity stunt. The debate about whether Tesla can make self-driving work has shifted, maybe not completely, maybe not permanently, but meaningfully, toward a different debate. The debate about whether Tesla can navigate the regulatory, legal, operational, and cultural obstacles between working technology and national scale. That is a harder problem in many ways, because it is not a problem that can be solved by a software update. It requires years of political negotiation, legal resolution, infrastructure investment, and public trust building. It is the kind of problem that does not get solved in a single quarter, or a single year, or even a single presidential administration. And that is what makes this moment so strange and so important. We may be living through the period where the hardest technical problem in the history of consumer technology has been largely solved. And the thing preventing you from sitting in the back seat of a car with no driver is not an algorithm. It may be a permit application sitting in a filing cabinet in Sacramento. If Tesla's biggest remaining problem is no longer the technology itself, then the next few years are not really a story about artificial intelligence. They are a story about institutions, regulations, lawyers, insurance actuaries, and local politicians deciding how fast the future is allowed to arrive. And that may be the most interesting automotive story of the decade, because unlike a software problem, nobody knows how to write a code fix for a bureaucracy, for the stories that the industry does not want you to know about, and the decisions that will define what you drive next. Stick with Driven to Distraction. The next chapter of this story is already in motion.